So we are proceeding with the compounds, and we have our first compound we are going to look at in the oxidation state of +3. It will be chromium 3 oxide. So there are a few things we may mention before looking at how it's formed and its reactions. So the first one is that chromium 3 oxide has other names. It can also be called chromia. These are not normally used, but for your understanding, and which you may find somewhere in any given mock, they may use these other names, chromia, or it can also be known as chromium cis-oxide. Chromium cis-oxide. So chromium cis-oxide. So that's the spelling. Cis-oxide. So it has two other names, that is chromia and chromium cis-oxide. So these are the other two names that can be used to mean chromium. So we can look at the appearance. How does this chromium 3 oxide appear? So it will appear as a green solid. It's green in color. It's a green solid. And then the other thing unique about it is that this chromium 3 oxide is amphoteric. So these are some of the notes you may need to take note of about chromium 3 oxide. So it's amphoteric. So which means that we shall see it reacting with bases as well as acids. So to start with, we can look at its reactions, which will mainly be reaction with the acids and the alkali, for example, sodium hydroxide. So we shall have this chromium 3 oxide. Let me borrow my black once again. I'll have my chromium 3 oxide. This is the formula. It has oxygen, 3 of them. So just in case you don't know how we're supposed to write the chromium 3 oxide, we have chromium in the +3 oxidation state, and then we have oxygen in the 2- oxidation state. So you have, I'll use the basic explanation that they used to tell us in O level, that this comes here, then the 3 goes there. So that's how we have our chromium 3 oxide. So this is a solid, a green solid. And how will it react with acids? So with acids, an example of concentrated hydrochloric acid, it will react to form chromium 3 salts, and in this case it will be chromium 3 chloride and water. So we can have this concentrated hydrochloric acid, and this will give us chromium 3 chloride, chromium 3 chloride, that's a soluble salt. So it's chromium 3 chloride aqueous plus our water. So shall we balance this equation? Yes, we can. So we have this side 2 chromium atoms, meaning this side we should introduce a 2. But this is directly affecting the number of chloride atoms. You get? Or chlorine. It's affecting the number of chlorine atoms. So which means that they are becoming 6, and I'll have to introduce a 6 here. When I introduce a 6 here, it will be directly affecting the number of hydrogen atoms, which means I have to introduce a 3 to make this side also 6. And I'll have my equation well balanced. So that's reaction with concentrated acids. And then so this is the condition is that it's hot and concentrated. Actually, you can include the hot and concentrated. Hot and concentrated. That's the particular condition here. And then with alkali, it will react to form a soluble product, which we saw, the chromite. And we saw that the chromite can also be called the tetrahydroxyl chromium 3, chromate 3, or the hexahydroxyl chromate 3 ion. So we shall have our chromium. I have the chromium 3 oxide reacting with these hydroxide ions from the sodium hydroxide. So one may ask, when do we form the tetra-aqua? When do we form the hexa? The tetrahydroxy and the hexahydroxyl. So most books will tell you that it will depend on the concentration of the alkali. So this side I'll have chromium, and then my hydroxide. And how do you write tetrahydroxyl chromate 3 ion? Have a 4 and then minus, and this is aqueous. So how shall we balance this? We can see that this side we have 4 hydrogen atoms, and this side we have only 1. So how are we going to balance this? If I introduce here 4, do you see that it will directly be affecting the charge? Yes, because if I introduce a 4, it means that I'll be changing the charge, meaning something should be missing. And what's missing? It's a way of balancing these hydrogen atoms. How am I going to balance them without directly affecting the charge? I may need to introduce water. But before that, let's look at chromium. If we looked at chromium, this side we have 2, and this side we have 1. So let's start by balancing chromium. So if I have a 2 introduced, then it means my charge would be changing to -2, which means I will need to introduce a 2 as well, so that to have a charge balanced. So what's remaining is that my oxygen and the hydrogens are not actually balancing with what I have on my right hand side. So what I will do, I will introduce water to help me balance this equation. So I'll carry this, carry it more to the right to have more space. So I'll have to introduce in water, which will help me balance my left hand side. So I'll have water coming in, so if I'm not changing my charge, it means I'm only going to deal with water to find a way of balancing the oxygens and the hydrogens. So how many oxygen atoms do I have this side? I have 8. And what of this side? I had initially 5. How many do I need to add to make them 8? It should be 3. So if I put here 3, oxygen will be balanced, right? And what of the hydrogens? You can see that I'll have balanced the hydrogens as well. So that's one way I can always know that this reaction will have water. If the charge cannot balance without introducing the water, it shows that it will be needed at a particular point. So that's the reaction with the alkali, and you form your chromite, which can be sodium chromite if the alkali here that was added is sodium hydroxide. So before we proceed to the ways of preparing, I can also give you another way how the hydroxide reacts without introducing this water, which may be even easier for you. So if I had my chromium 3 oxide. I have my chromium 3 oxide, and then I have my hydroxide. Remember the different ways of writing the chromite? We had another way. So this is the hydroxide ions. So I can also have this other way of writing the chromite. So you can see that as well will be in the oxidation state of +3. So instead of having water introduced, it will just be a product in this particular equation. So if you're someone who finds it hard to balance equations, you can actually stick on this one, you get? But it doesn't limit you from understanding this as well. So how do I balance this? Should I start with chromium? Yes. I have 2 this side, I have 1, so I put here 2. And then that will be affecting my charge, taking it to -2. So which means I should also introduce a 2 here before I proceed to anything. Then what of the oxygen? Oxygen I have 3 plus 2, that is 5. And what of the right hand side? They are also 5. What of the hydrogens? They are 2. And I have my equation balanced. So lastly, about the reactions, I would also want to point out that we shall not have any reaction with water. Why? Because of the chromium 3 being insoluble. So it's insoluble in water. That's why it can't react with it. So we can proceed on to see how the chromium 3 oxide can be prepared. Okay. So now, looking at the different ways of forming this chromium 3 oxide, there are about 4 ways. I group them into 4 personally because it's the easiest way you can remember. The first one is through burning in air. Burning in air, we are going to see what's burnt. And then the other one is dehydration. Have dehydration. Of course, what we are dehydrating should be containing water. And then we have decomposition, and specifically thermal decomposition. So we have decomposition, we have redox reactions. And redox reactions. So I group them mainly into these 4. There is burning. What are we burning? We shall be burning chromium in air to form the chromium 3 oxide. Then dehydration. What are we dehydrating? It's hydroxide. So we shall be dehydrating the chromium 3 hydroxide. And then the decomposition. So this decomposition, we shall be looking at the thermal decomposition of a compound known as ammonium dichromate. Then the redox reactions, we are going to see a reaction between compounds like sodium dichromate and carbon. So here we can have sodium dichromate and carbon dichromate. Dichromate, we are going to see it under chromium 6 mainly. That's when we shall appreciate it more. And carbon. Then here we are going to see ammonium carbonate. Ammonium dichromate. Ammonium dichromate. So after you covering the part of elements in the oxidation state of +6, you'll be able to appreciate these two more. Then still under decomposition, we shall also see the chromium salts as well. The chromium salts, an example, chromium sulfate, chromium nitrate, you get? So also those will be decomposed to give us the chromium 3 oxide. So let's start with the first one, which is burning in air. So what will happen is that the chromium will be burnt in air, specifically oxygen. You can say it's burnt in oxygen to form the chromium 3 oxide. So you will have your chromium and then oxygen. Make sure you write this oxygen well, not like mine. Gas to give us chromium 3 oxide, and that's a solid. So balance it, put a 2 here, put a if we put here 3, it will be it won't be balanced, so we shall need 3 out of 2, not so, to balance oxygen. And how shall we remove the fraction? Multiply everything by a 2. So this will be 3, this will now change to 3, and then this will change to 4, and we shall have a 2 here. So that will make our equation well balanced. So we can delete out this black and have our clear equation. So when you are looking at these equations, you need a perfect understanding of the oxidation states, which I tried to explain very well, and that will help you understand these seemingly confusing reactions, yet they are very easy to understand if you follow with me. So the second one is chromium 3 hydroxide. So the chromium 3 hydroxide will be dehydrated. How? By heating it simply. So you will heat chromium 3 hydroxide, and this should give you the chromium 3 oxide and then water as a product. That's why we call it dehydration, because we are removing water molecules. So, and water also given off. So how are we going to balance this? Let's look at chromium. Chromium this side 1, chromium 2. So put here 2, and this means that it will dictate everything else. So how many oxygens do we have? Oxygen, there are 6. Out of this side I have 3 here and 1. How do I balance this to make 6? I can introduce here 3, because if I introduce a 3, I will see that even my hydrogen will obviously be balanced. 3 plus 3 make it 6, and that will be my equation. So let's look at the next equation, and this is where I need you to pay so much attention, because it can be confusing, but the moment you understand this, it will be very easy for you. So we have this thermal decomposition of ammonium dichromate. So this is something you need to understand rather than cramming. So how we write this formula, you appreciate it more under chromium 6. I'll just give a brief explanation about this formula. So this oxidation state of +6, we shall see that there are 2 compounds, and one of which will be the dichromate. So this is called a dichromate, like that. So if you calculate the oxidation state, how are we calculating this oxidation state? We shall let the oxidation state of chromium be X, and in this case we see that there are 2 chromium atoms. So we multiply this X by 2 to have 2X, and then we add oxygen. What's the oxidation state of oxygen? Negative 2 And how many are they? They are 7. And then equate to the overall charge of minus 2. So go on to make X the subject. This will give us negative 2 plus 14. That will be 12. 12 divided by the 2. That will give us, have I done it well? Yes, 12 divided by 2, it will give us 6. So that's why we call it dichromate, but in the oxidation state of plus 6. So whenever I see this, just know that is a plus 6. The other one we shall look at is the will be this one here, in that form. You get? We shall look at this in depth. We may not need to look at it right now. No rushing. We have our time. Let's understand this. So this is where it comes from. When you look at this, and ammonia, which has just a positive charge, so I'll still do it the O-level way. Bring the 2 this side, bring the 1 here, and that's how we come up with the 2 ammonium molecules here in the ammonium dichromate, whatever, powder or a compound. So this one is going to be decomposed in a reaction that we have called the thermal decomposition reaction, or this is also called the chemical volcano because of how everything appears while the reaction occurs. So you know, a volcano meaning we have a lot of something like, okay, just go and watch how a volcanic eruption occurs. You will understand what I mean. Or simply look for this reaction, how it occurs in the lab. Unfortunately, I can't demonstrate it here, but that's not our main point today. So this will be decomposed at a very high temperature. So we can put here heat. And what are we going to form? So this is where I need you to understand. We are looking at a product which will be in the +3 oxidation state. How does that occur exactly? So this is what occurs. Follow with me. Let me use blue for the explanation part. So in this compound, I have 2 molecules. I have the ammonium ions, and then I have the dichromate ions. So I have the dichromate ions in the +6 oxidation state. So if I look at these reactions independently, I'll see that here the main reactant will be chromium. So I'll write here just +6, chromium +6. You get? I'm just looking at the main reactants to explain how the products will be. So this one will be changing to +3 also. So how does it change to +3? We should have reduction. You get? We should have reduction, which means that I'm adding how many electrons? I'm adding 3 electrons. So I must add 3 electrons. But where are these electrons coming from? They will actually be coming from the nitrogen here. So here the main reactant is nitrogen, which is in the +3 oxidation state. Get? I mean the -3 oxidation state. So here I have my nitrogen with a 3 minus. You get? So here, how am I coming up with a -3? Because I know hydrogen carries a +1. So if you calculate the oxidation state here, you end up with a -3. How? If I have X for nitrogen plus 4 multiplied by 1, the +1 for hydrogen, because each hydrogen ion carries a positive charge, and equated the overall charge here, which is 1, my X will be -3, not so? and that will be the oxidation state. That's why I'm saying here it's in the -3. So meaning here it has gained 3 electrons in this complex. You get? So it's going to lose these electrons and will be taken up by this chromium now. So I'll have nitrogen going to the oxidation state 0. You get? And we know that in the oxidation state 0, it actually appears to be as nitrogen dioxide. Then we shall have our 3 electrons given out. You get? So here you can balance it and put here 2. You get? And then I'll have this also multiplied by a 2 to make it 6. Okay. So this will be a 2. And you have a total of 6 electrons given. How are these 6 electrons going to be utilized? They will be utilized by this chromium. The chromiums in the +6 oxidation state. Remember here we have 2. You get? And each needs 3. So actually these 6 will be utilized by these. That's how we are going to come up with a 2. The chromium in +6 oxidation state forming 2 chromium in the +3 oxidation state, which will be in the chromium 3 oxide. So from that you should have the understanding of where everything is going to come from. So meaning in our reaction we shall have chromium 3 oxide, and we shall have nitrogen gas as well as a product. So let's write this full equation. After understanding this, that we shall have nitrogen dioxide and the chromium 3 oxide, then we can have our equation. So let me erase this. So I'll complete my equation. I'll expect a product of chromium 3 oxide and then I'll have my nitrogen gas as well. And where is the hydrogen now going? The hydrogen will be taken by, will combine with some of the oxygen to form water. So I have water as well. So plus water. So let's balance this equation. So this side we have how many nitrogens? We have 2, and this side 2. What of the hydrogen? We have 4 by 2, that's 8. And what of this side? You have 2. So we multiply this side by a 4 to make them 8 as well. What else? Chromium 2, chromium 2, oxygen 7, oxygen 7. So that's my equation, well balanced. And that's the reaction involving the thermal decomposition of this ammonium dichromate. So another one, under the decomposition, we talked about the decomposition of its salts. So the salt here, I can either use chromium nitrate, which will give me chromium 3 oxide, nitrogen dioxide, and oxygen gas. You get? Or I can also use the chromium 3 sulfate. So you can choose what you take. It will still be for your own benefit. As long as you know the products, you can balance the equation. So this is a solid, and it will be heated to give us 2 products. So still here is a point of confusion which I find with most students. So many don't know what the products here will be. So after knowing that I'll have the +3 oxidation state of chromium 3 oxide, what else will be formed? Shall I have sulfur dioxide? Shall I have sulfur? Shall I have sulfur trioxide? That will be the question. So that comes from the understanding of which oxidation state is the sulfur here. So if you look at this molecule, what is the oxidation state of sulfur in the sulfate? It is actually +6. It is a +6 oxidation state. So to know which product it will be, I'll look at these products, sulfur, I'll look at sulfur dioxide and sulfur trioxide. So which of these will have a +6 oxidation state of the three? It will actually be sulfur trioxide. So to maintain its oxidation state, it will form this product in the +6 oxidation state, which will be sulfur trioxide. So we expect to have products here, chromium 3 oxide and sulfur trioxide. And sulfur trioxide. So that's how I know the products. This is a gas, and then I can balance my equation. How am I balancing? Chromium 2, sulfur 3, and how many do I have this side? I have only 1, so I multiply here by 3. If I multiply by a 3, how is that affecting my oxygen? These are 12, and what of this side? They are also 12, and my equation is balanced. Very easy ways of balancing these equations. So we can look at the last one, which is the redox reaction involving the sodium dichromate and the carbon. So I can push this side. We push a little bit, have more space for writing our fourth or fifth reaction. So this will be fifth reaction. So we have a decomposition, the redox reaction between sodium dichromate, this is a solid, normally dichromates are orange, and then I have carbon. So still here, I'll also need the knowledge of oxidation states to know which products. The main point why I emphasize oxidation states, because I don't want you to assume that everything here is crammed. No. Chemistry, it's not all about cram work. It's about understanding the main idea behind. So let me correct this. So if we look at our dichromate here, it's in the +6 oxidation state. And how many are they? There are 2. Not so? And it's changing to the +3 oxidation state. So how many electrons shall each need to change the +3? It will be 3 electrons. You get? Which means that the 2 of them will need a total of 6. We'll need a total of 6 electrons. We'll need a total of 6 electrons to form 2 chromiums in the +3 oxidation state. Then where are these 6 electrons going to come from? These 6 electrons will actually come from carbon. So if I have carbon, I know that each carbon, of course, if they are needing 6, it means that at least I'll get 3 electrons from each carbon, so that I have a total of 6. You get? So I'll have this carbon losing 6 electrons. You get? But remember, each carbon can only give you a maximum of 4 electrons. And so can give you a maximum of 4 electrons, which means that we shall need 2 carbon atoms to give us these 2 electrons. So from this, I want to derive a way of showing you how the products will be formed. The products that will be formed we shall have a carbonate. So what is the oxidation state of a carbonate, of carbon in this? It is actually +4. And so it's a +4, meaning here it will have what? It will have lost 2 electrons. I mean 4 electrons. And where are the other 2 going to be? It will be in another product, you get, where carbon will have lost 2 electrons. And which product is that? If we look at the oxides of carbon, we know that in carbon monoxide, actually carbon will be in the oxidation state of +2. You get? How do I know? Because if I have X as carbon, then plus the -2 for oxygen, equating the overall charge 0, X will be equal to 2. So that's how I know the oxidation state. So to account for these 6 electrons that are lost, I'll have a carbonate to give me, this shows that carbon used 4, lost 4, then in the carbon monoxide it will have lost 2. So meaning in the products I expect to have a carbonate, I expect to have carbon monoxide. So I'll have my chromium 3 oxide, chromium 3 oxide. I'll have a carbonate, which in this case will be sodium carbonate. So I expect everyone to be knowing how to write sodium carbonate, the formula. I have a 2 here, and then we have our carbonate, and then we have carbon monoxide, which is a gas. So how do I balance this equation? I'll have 2 sodiums, 2 chromium, 2 chromium. What of the oxygen? They are 7 balanced. What of the carbon? I have how many? 1, 2. So I will need a 2, and I'll have my equation well balanced. And that's the reaction that involves the reduction of chromium 6 of the dichromate by carbon to form the chromium 3 oxide and sodium carbonate as well as carbon monoxide.